All right, so we're going to put those postulates we learned about last class to good use. Before I go to the postulate, I want to go over a word that you probably are looking at going, I already know what that means, but in math it's very specific, and that's the word between. Between, points must be collinear if they are defined as between. So if you see on this line right here, clearly A and C are on the line, as is B, and B is between A and C. Now I cannot stress this enough. In math, and it's unfortunate I'm not in class to really show you this or kind of drive this point home, but we don't measure these lines. We don't assume their length in any way. We're not allowed to do that. I'm not allowed to say AB is equal to BC. We don't know that. We can only speak in absolute fact. The only thing I know is B is between A and C. That I can say. I cannot say it is midway. It is at the midway point. That has to be told to me, and we'll learn about that a little bit later. Right now, all I can say is B is between A and C. Now, obviously, this B is off the line. If you're off the line, you can't be between. And even if I were closer to the line, if I kind of move this over, I'm still not between. I've got to actually be on the line to be between. Okay? And that leads us to our first postulate. And that is the segment addition postulate. In my last video, I told you to kind of keep in the back of your mind something, and this is really what it is. And that is, if B is between A and C, then AB plus BC equals AC. That I can say for a fact, okay? I can't tell you AB and BC are equal. I know they look equal here, but I don't know that. But what I can know, or what I do know, I shouldn't say can know, but what I do know is if I take segment AB and I add it to segment BC, that has to equal AC. So like, let's put some numbers in. Let's say AB was 4 and BC was 5. AC would have to be 9 because 4 plus 5 is 9. Okay? And that's what makes it a postulate is we assume it to be true. No one's ever shown a situation where you can put a point between two letters, and if you added up the two segments, it wouldn't equal the whole segment. Put another number in. Let's put 6 in right here, and let's put 2 in right here. I know it doesn't look right, but it doesn't matter. You can only go with what you're told. So I'm going to say AB is 6 and BC is 2. But what I do know for a fact is AC would have to be 8. 6 plus 2 is 8. And that's what makes something a postulate, is that it's assumed to be true, and we can't, and no one has discovered a way to show otherwise. So this is the segment addition postulate. We use it quite often in the first couple of chapters of the year. And that's AB plus BC equals AC, or whatever letters you want to use. If this was a D and this was an F and this was a Q. Okay, so what we're going to do here is we're going to do some math and how it applies to this postulate. So if you notice here, I have AD equals 20. Well, how do I get to AB? I would have to add AB, BC, and CD. So when I add these three expressions, 4x and 6x is 10x, 10x and 12x is 22x, I get 22x. I get 2 plus 8 is 10, and 10 and negative 1 is 9. Hopefully we can recall that from our Algebra 1 years. And that's got to equal 20. Put that in. So now when I subtract 9 from both sides, 22x equals 11. And when I divide 22 on both sides, x equals 1/2 when I reduce it. That's my answer. And I have the first one be a fraction because I don't want us to be afraid of fractions. Okay, you have to understand, sometimes fractions, those are the answers. And if I plug that back in, 4 times 1/2 is 2, 2 plus 2 is 4. So this answer right here would be 4. 6 times 1/2 is 3, 3 plus 8 is 11. That answer would be 11. 12 times 1/2 is 6, 6 minus 1 is 5, and that answer is 5. And right away, I don't care that you may think BC is not double the size of CD or triple the size of AB, or you might think AB is bigger than CD. It doesn't matter. You can only use the numbers that you were given. And if I do that, well, 4 plus 11 is 15, and 15 plus 5 is 20. It does work out. If I take a look at the second one, I had a little more to erase right here. We have 3x plus 5 plus 8x minus 4 for AB and BC, and then CD is 5x plus 2. Once again, it's important to read the questions carefully and answer the question. I'm not told what AD is in this situation. I'm only told what AC is. AC is literally this. It's from A to C. So it's only these two sections that are set equal to 34. So when I do that one, 3x and 8x is 11x, plus 5 and a negative 4 is a plus 1, and that's set equal to 34. Well, 11x, after I subtract 1 to both sides, is going to be equal to 33. And then when I divide 11 on both sides, my x equals 3. And I can plug that in. 3 times 3 is 9. 9 plus 5 is 14. 8 times 3 is 24. Minus 4 is 20. 14 and 20 equals 34. I can use this x, though, to find CD. CD is going to be 17. 5 times 3 is 15. 15 plus 2 is 17. So that question absolutely can be asked, and you do need to be aware of it. Now, my last one right here. Whoops, did not erase that. Sorry about that, guys. My last one down here, now we're using BD. So think about that. Where's BD going? Right there. So now 3x and 4x is 7x. 12 and 1 is 13. Oops. There we go. And that's going to equal my BD, which is 9x minus 3. Well, if I subtract x on both sides, 7x on both sides, I'm going to get 2x. If I'm going to add 3 on both sides, I'm going to get 16. And hopefully our algebra skills at our level, we can do that in one step. When I divide 2 on both sides, I get 8. And there's my answer. 2 times 8 is 16 minus 6. This answer is 10. It's not going to affect my BD, though. 3 times 8 is 24. 24 and 12 is 36. And then 4 times 8 is 32. 32 and 1 is 33. So 33 and 36 is 69. Well, 9 times 8 is 72. And 72 minus 3 is 69. So it does check out. Now on this one here, okay, I have AC equals 31 and BC equals 30. Now that's okay. I know it seems weird, but you have to use the numbers that are given. So basically, BC is 30. Well, what would AB have to equal? It would have to equal 1. Okay? So if AB is 1 and BC is 30, then AC is 31. Okay? Let's take a look at what happens when a problem is not well made. Our 3y plus 12 would equal 30. And that's okay. We have 3y equals 18 when we subtract by 12. And we get a y equals 6. Now here, we have 2x plus 6 equals 1. Well, when I subtract 6, I get a negative 5. And then when I divide by a 2, I get x equals negative 5 divided by 2. And I know it's a negative fraction, but that's okay. 2 times negative 5 halves is negative 5, and negative 5 plus 6 is 1. The issue comes here, and this is why it's important to check your work and make sure things make sense. When I plug in negative 5 halves here, negative 5 halves times 4, well, 4 divided by 2 is 2, and 2 times negative 5 is negative 10. So 4 times negative 5 halves is a negative 10, plus 1 is a negative 9. One thing we can never have is a negative distance. So in this case, we would argue the problem is flawed. I still did it correctly mathematically using the segment addition postulate, but unfortunately, when you get a distance that is negative, that basically means you have a flawed problem with no solution. And we will stop there for this video. Next will be midpoints.